July 1941, Suffolk, and the field instruction starts before the smoke fully clears. A War Office team stands beside an awkward tripod and a drain pipe tube while Home Guard men wait for the next bottle. The bottle is glass, but the fear behind it is armour. What looks like a crude farm improvisation is part of a national emergency weapons programme. Its real logic was not elegance, but time. The device in that training line was tied to a weapon Britain hoped would buy minutes during an invasion alarm. The object at the centre of that system was the No. 76 S.I.P. grenade, also called the AW bomb. It was a British self-igniting incendiary packed into a half-pint glass bottle with a crown cap. It was built to shatter, ignite, cling, and choke a crew space long enough to break a drill or a charge. The contradiction was obvious even in 1940. Britain was trying to answer modern armour fear with bottles. The reason that answer entered production anyway sits in the shortages of the invasion summer. After Dunkirk, the British Army was short of anti-tank guns and short of ammunition for the guns that remained. Contemporary summaries of the Northover programme traced that shortage directly to what was lost in France. Home Guard units were then pushed toward ad hoc anti-tank measures because regular formations took priority for modern weapons. This was the operational problem behind the bottle. A platoon on a roadblock needed something available now, not a factory-perfect answer next year. The requirement was immediate issue, low cost, simple handling, and at least some effect against vehicles and crews. The first key step did not begin in a field platoon, but in an industrial demonstration. On 29th of July 1940, Albright and Wilson of Oldbury showed the RAF a white phosphorus ignition method using glass bottles. The test involved bottles thrown at wood and into a hut, and the ignition effect was immediate when the glass broke. The RAF did not want white phosphorus as an incendiary bomb ignition source because of safety concerns. The demonstration still proved a different point. A bottle could ignite itself on impact without a conventional fuse. That shifted the design question from how to light a petrol bomb to how to standardise one. War Office documentation later cited in reference summaries identifies it as the self-igniting phosphorus grenade and the AW. Grenade! The naming sequence also stayed in circulation. Factory and field language kept the Albright and Wilson origin in the AW name, while troops and manuals used number. 76 and S.I.P. The weapon entered service not as a mythic secret project, but as a fast standardisation of a dangerous chemistry trick. Content reference, S.I.P. Index to S4. Imperial War Museum's catalogue notes give the live number. 76 S.I.P. Mark I as a short-necked half-pint glass bottle. The same catalogue records the filling in practical workshop terms rather than abstract theory. It lists yellow phosphorus at 128 cubic centimetres, water at 21 cubic centimetres, benzene at 110 cubic centimetres, and a crude rubber strip in the bottle. That rubber was not packing waste. It partly dissolved in storage and increased adhesion when the mixture hit a target. The bottle was closed with a crown cap because the design needed cheap sealing and mass handling. Content reference, S.I.P. Index 5. The sticky behaviour was the engineering quirk that made the bottle more than a simple flash weapon. If the liquid only splashed and ran, much of the effect was wasted on metal slope or mud. If it clung, it burned where it landed. British descriptions repeatedly frame the grenade as both incendiary and smoke-producing. The impact ignition gave flame, but the smoke and fumes were part of the intended crew disruption effect. This is why the weapon sat in the anti-armour conversation, even when its penetration value was 0. IWM notes also preserve a detail that matters for field use. There were 2 issue forms with different caps and different handling expectations. The red-capped version was for hand throwing, and is described with a typical throw range of up to 30 yards. The green-capped version used thicker glass for firing from the Northover Projector, and is described with effective range up to 100 yards. That colour coding was not cosmetic. It marked a packaging solution to the same ignition chemistry under 2 different launch stresses. A Home Guard reference summary gives the grenade weight as 1 pound and 3 ounces and describes the fuse action simply as self-igniting upon breakage. That plain wording captures the tactical attraction. No fuse timing had to be set under pressure. No striker drill had to be completed in the dark. The hard part came earlier in storage, transport, and confidence. A grenade that ignites by breaking forces every handler to think about accidents first. Content reference S.I.P. Index 8. The manuals reflected that fear directly. Reference summaries of the War Office training manual state that strict instructions ordered safe storage, preferably underwater, and never in a house. That instruction is one of the clearest signals of what the weapon really was. It was useful because it was dangerous. The same chemistry that removed a fuse also removed most margin for careless handling. Britain accepted that trade because invasion planning was being written against the clock. Content reference, or S.I.P, index is nice. The second half of the system was the launcher that extended the bottle beyond throwing distance. The War Office label was plain, projector, 2.5 inch, though almost everyone called it the Northover Projector. IWM and other summaries describe the weapon as an ad hoc anti-tank launcher for the Army and Home Guard. Its origin was equally improvised. Robert Harry Northover, a Home Guard officer, designed it and pushed it upward by direct demonstration. Churchill saw it, approved it, and production followed in 1940. Content reference. Website. Cyril. Index. Testiamn. The projector was mechanically simple by intention. A WM describes a hollow metal tube on a tripod with a rudimentary breech. The same entry notes black powder firing and ignition by a cap from a toy pistol. Other summaries describe the cap as a musket percussion type, and the whole tube as drainpipe-like. Nothing in the design suggests precision artillery. Everything in the design suggests a weapon that could be built quickly with limited machining depth. Content reference, Waysite. Index, D11. Its dimensions reinforce that impression. The IWM catalogue example records a caliber of 2.5 inches and overall dimensions of roughly 71 by 36 by 26 inches. Reference summaries for the projector also give a weight of about 27.2 kilograms. That was not a shoulder weapon. It was a crew-served stopgap that had to be emplaced, aimed, and worked under local cover. The launcher extended reach, but it did not remove exposure. The men serving it still had to remain close to roads and lanes where armour would appear. Content reference, Website. Index C just 12. The range figures show the same compromise. IWM gives 100 to 150 yards as the effective range. Other summaries describe a theoretical maximum around 300 yards and practical accuracy much shorter. For a roadblock fight, that still mattered. It doubled or tripled the reach of a thrown bottle. It also let a platoon attack a vehicle before the vehicle reached the barricade line. The cost was inconsistency, smoke signature, and crew risk at the breach. Training and drill material also reveal how the Army tried to domesticate the danger. IWM collections include Northover drill projectiles marked in the base as Northover Projector, drill projectile. One catalogue entry describes a rubber bottle-shaped drill grenade with a cardboard transport tube. Another notes earlier drill versions made of wood and weighted with metal. The recorded drill projectile dimensions are about 64 mm in diameter and 153 mm long. This matters because it shows the system was not just issued, but trained as a repeatable sequence. Britain had to turn a frightening bottle weapon into muscle memory. That training sequence likely looked controlled on paper and tense in practice. Bottle selected, cap checked, charge measured, tube loaded, position called, line cleared. Then, the moment that made crews wary arrived. The launcher used black powder and a brittle incendiary container in the same action. Too little powder could drop the bottle short. Too much powder could break it inside the weapon. Even correct firing could flood the position with smoke and expose the crew. This is the point where the number 76 and the Northover Projector stopped looking like separate museum objects. They were a combined emergency system. The grenade solved ignition without fuse complexity. The projector solved range without demanding a modern anti-tank gun. Together they offered Home Guard platoons a real, if uneven, method for attacking a vehicle approach. Neither component was elegant. Both components were designed around what Britain could produce quickly in 1940 and 1941. Production scale shows how seriously that emergency answer was taken. Reference summaries for number 76 state that well over 6 million had been manufactured by August 1941. That is not a trial quantity. That is industrial distribution for a nationwide defensive scheme. Northover production expanded in parallel. By August 1941, more than 8,000 projectors were in service, and by early 1943 the total reached 18,919. The numbers do not prove effectiveness by themselves, but they prove institutional commitment under pressure. Content reference, or S.I.P. Index ends. 17. Procurement friction still ran through the system. The projector was accepted partly because it was cheap, with summaries citing a cost just under £10 excluding the tripod. That economy was a feature, not an insult. A weapon that could be issued widely mattered more than a better weapon that did not exist in sufficient numbers. War Office and Home Guard Command also had to sell confidence as much as hardware. Later accounts cited in Northover summaries describe official propaganda emphasizing simplicity and low maintenance. That language reads like logistics management disguised as morale. Content reference OS-Site. Index S18 des. The first real proof of a weapon like this was never a brochure claim. It was handling in mud, darkness and nerves. The Home Guard photograph record from Suffolk shows War Office instructors training Northover teams in July 1941. That timing matters. By then the invasion panic had matured into organised local defence routines. The bottle and projector were no longer just last-ditch ideas on paper. They were in the instruction cycle, on actual ground, with actual crews learning arcs and distances. Content reference, OS-Site. Index S19. The number. 76 itself also had a layered tactical intent against armoured vehicles. IWM Tech states the shattering bottle produced immediate ignition and a cloud of smoke with noxious fumes. The same note says the fumes could force AFV crews to don respirators and reduce fighting effectiveness. That is a narrow but realistic effect. The bottle was not expected to punch armour plate. It was expected to blind, smoke, burn fittings, contaminate vision slits, and disrupt the crew drill at close range. If the crew bailed out, the bottle had done more than a normal petrol splash. Content reference, OS-Site. Index 20. British descriptions also imply a second tactical use. The cloud acted as screening smoke at the exact point of impact, in a lane ambush that could hide the next movement for a few seconds. In a village street, it could also confuse the target crew about where the attack came from. These were small advantages, but small advantages were the whole logic of Home Guard anti-tank planning. The system was built around delay, disorder and forcing mistakes. It was not built around dual-style destruction. Then came the part every crew remembered. Misfire, overcharge or bad bottle tolerance could turn the launcher into the hazard. Northover summaries state that number 76 grenades sometimes broke inside the breech or barrel and injured crews. They also describe smoke from proper firing lingering long enough to reveal the weapon position. That is the mid-story truth of the system. The same smoke that could blind a target could also mark the firer. The same glass that made impact ignition possible could fail before the shot was complete. This was not hidden in later memory. It appears in mainstream summaries of the projector and in Home Guard references. The weapon was accepted with defects, not despite unknown defects. That is an important distinction in wartime engineering. Engineers and commanders were not confusing the number 76 system with a true anti-tank gun. They were assigning it to a gap that still had to be covered that month. The measured standard was not perfection, but whether it improved the roadblock plan. The skepticism about anti-tank effect also surfaced in trials. Number 76 summaries record Stuart McRae describing concern at Farnborough that tank crews might be trapped and burned. His account then cuts the expectation down sharply. After seeing the bottles, the drivers were willing to take the chance. Trials on modern British tanks later concluded that Molotov and S.I.P. attacks caused the occupants no inconvenience whatsoever. That line is one of the most useful evidence points in the entire story. It narrows the claim and forces the weapon back into its true category of limited conditional utility. Content reference, A-Site. Index S24. That result did not make the number 76 irrelevant. It clarified where it could still matter. An exposed crew, a stalled vehicle, a soft-skin transport, a firing slit, an open hatch, a lorry park, a fuel point, or panic in confined streets all remained plausible targets. The grenade was also a psychological instrument in defence planning. It gave lightly armed units a weapon with immediate visible effect and some standoff extension through the projector. In 1940 and 1941, and that confidence had military value of its own, A platoon that believes it has nothing often breaks before contact. Content reference DOI site. Windex 25. Operational reality therefore split into two tracks. On one track, the number 76 and Northover combination was a serious issued system with manuals, drill rounds and mass production. On the other track, reports and recollections preserved its flaws, safety risk and doubtful effect against modern tanks. Both tracks are true at the same time. This is why the weapon still looks strange in collections. It belongs to the category of credible emergency engineering. It is not a joke weapon, and it is not a miracle weapon. Content reference. S.I.P. Index Respirators 26. There was also a storage and distribution burden that lasted beyond training. The same references that describe the mixture also repeat the underwater storage rule and the ban on keeping it in houses. That requirement complicates ordinary local issue practice. Home Guard units needed safe points, containers, and discipline for a weapon already designed for impact breakage. It is one more reason the grenade fits the Home Guard story so closely. It was simple at the moment of use and awkward in every stage before use. Wartime expedients often look exactly like that. Content reference. Website, Studios, Index 27. The archival trail reflects this long after the invasion emergency passed. The National Archives catalogue still lists WW0185/23 as Northover Projectors, with file dates spanning 1940 to 1948. That date range suggests more than a single panic memo. It points to continuing administration, ammunition questions, and post-emergency record life. The object also survived in museums as both launcher and drill projectile, which preserves the system as practiced, not only as described. Those collection records matter because they freeze the small details that wartime summaries often skip. Cap colours, drill bodies, transport tubes, and embossed markings turn theory back into hardware. The afterlife of the number 76 also confirms the chemistry never became harmless. Reference summaries note that Home Guard caches were hidden during the war for invasion use. Not all cache locations were recorded, and some were lost. Later builders occasionally found them during excavation. The same summaries state that the grenades are still treated as dangerous and are destroyed by controlled explosion. That is a rare kind of legacy. A temporary anti-invasion bottle remained an ordnance problem decades after the invasion threat was gone. By the early 1940s, the projector itself was already living on borrowed time. Northover summaries describe a lighter Mark II attempt in 1941, but few were produced. They also show the weapon staying in service until other Army weapons replaced it. One volunteer description preserved in those summaries is unusually precise in tone. The projector was accepted gratefully until something better arrived. That sentence explains the number 76 system better than any later myth. It was a bridge built from shortages, not a destination. The opening scene in Suffolk looks different with that context restored. The men on the line were not training on a curiosity. They were training on a national compromise between chemistry, industry, and invasion fear. The bottle was glass, but the program behind it was industrial, doctrinal, and bureaucratic. More than 6 million number 76 grenades and thousands of projectors mark the scale of that decision. The cost line is plain in the records. Crews worked a brittle phosphorus bottle through a smoky stopgap launcher at close range. Content reference. A-site, Scarce C, Index 31. The paradox is why the weapon stays memorable. It looked like a bottle and functioned like a chemical anti-crew ambush tool. Its measured consequence was not armour penetration, but disruption under invasion conditions. Its limits were real and the archives do not hide them. Its usefulness was also real because Britain kept issuing, drilling and filing it. Emergency weapons leave the clearest fingerprints when they are both dangerous and ordinary. Britain standardised fear into a bottle and called it number 76.